Good evening to one and all present here. Welcome back to this third day of National Workshop on Data Analysis using SPSS. On this third day, we have a resource person, Professor Haribhaskar from Department of Management, Kristu Jayanti College, having a wide knowledge of derivative markets, and he specialized in quantitative techniques, and he's having expertise in taking a software like SPSS and EViews. So the great person is with us today for today's session. And one of the information which I would like to share with you is the data set what we have shared yesterday. The same data set we are going to use for this today's session also. So please have that same data set to have a hands-on experience on today as well. So with that, we will start this today's session, and the speaker of this day is Professor Haribhaskar, and I hand over the session to Haribhaskar. Haribhaskar sir, over to you.
Thank you, Madhu sir. Thank you for the introduction. Very good evening, dear participants. So I'm happy to discuss with you the usage of SPSS and the use of t-test for doing our analysis today in today's session. So I'll be sharing my PPT here. So I hope before we get into the t-test, I hope you got input about what is statistics and what the analysis we are doing by using statistics for our research purpose. And in yesterday's session, I hope you received input about how the SPSS software is used and what are the different types of data, how the data are merged together in order to make use of our analysis. I hope you got input about all those things. So with that input, today we are going to use a tool called t-test for our analysis. Okay, so I'll get into that t-test. So before we get into the t-test, we must be having the clarity that why we are using the t-test. So t-test we are able to use under certain circumstances. So I'll give you overview. After that, I'll be discussing about it. There are different t-tests. I'll be discussing about different types of t-test and which are the circumstances we are using those tests. I'll be giving you the clarity. And before that, if you want to use the t-test, we must be aware of population standard deviation. Okay, so if you know the complete population standard deviation, then only exactly we are able to use a t-test. And under that, there are two categories. If you know, actually the t-test has to be used for the sample size, meaning sample size where it is very less. Yeah, but in research we are using for even for high samples also, but the accuracy level will decrease if you are using for high sample size. But if you are using for less sample size, then we are able to get more accurate in t-test. So if we know the population standard deviation, then we can proceed to the t-test. Okay, so as I already said, without knowing population standard deviation also, because the research, for example, if you are doing marketing research, there we don't know the exact population size. Okay, so randomly we'll collect some 150, 200, 300 samples, and that will be using it for t-test. There we don't know exactly the population standard deviation. If you know that all the data related to population, only then we are able to calculate population standard deviation. Actually, we don't know. Without knowing that also, we are able to use the t-test. It's not mean that if we don't know the population standard deviation, we cannot give the data in the SPSS. We cannot get any output for that. We can get, but it is about the accuracy. Okay, so if we have the population standard deviation, we are able to use the t-test and we are able to get accurate data. If we don't know the population standard deviation, then also we can use, but the accuracy level will decrease. Okay. So, and under the condition of population, when we know the population standard deviation, there are two circumstances. Population standard deviation we know for the limited population, but the sample which we have selected, that may be either below 30 or above 30. Generally, in the standard statistics, we used to say that if the population, from the population, if sample size is 30%, there are some calculations to determine the sample size. But even though generally in general assumption, we used to say that if you have 30% of the sample from the population, then we are able to get the exact result. Okay, so the result which we are obtaining from that analysis, that can be applied for the population also. That is a general say about the statistics. And here, if we have the sample size of 30, as I already said, t-test is used for the concise sample size or the less sample size. So if we have the 30 sample size or greater than 30, less than 30, then we are able to use t-test. If the sample size is greater than 30, then we can go for z-test. There is a test called z-test that we can use it. Okay, so here we are going to learn how we are going to use this t-test. Okay, as already said, this can be used for sample size less than 30, and in due practice, we are using it for sample size greater than 30 also. Okay, and without knowing population standard deviation also, we are using it. I'll be telling you how we are giving the data in SPSS and how we are using and how we are using this different types of sample. Different types of t-test I'll be telling you. So these are the three types of t-test we are using it for the research purpose. One sample t-test, paired sample t-test, and independent sample t-test. There are three tests for the three different purposes we have. Okay, so one sample t-test, paired sample t-test, and independent sample t-test. I'll be telling you why we are using these different t-tests and that what are the circumstances, what are the conditions for that. I'll be telling you one by one. And after that, I'll take example for each and every type, and we'll be executing it in the SPSS. Okay. So first one is one sample t-test. So under one sample t-test, we'll be taking only one set of data from the population. Okay. So from the same population, we are taking one sample. Okay. That is one variable we are taking. That variable we are testing with the population. Okay. Generally, this t-test is also called a single sample t-test, or it is also called as the variable. It is also called as one sample t-test. Like that, it is called single sample or one sample t-test, because we are taking only one variable from the data which we collected. Okay, so when we are using it in the SPSS, I'll be telling you how why do we say this as a one sample t-test. Okay, so this can be used under certain circumstances. Like one example I have given here. If we know the standards, if we know the standards for population, for example, we are taking we are collecting samples. Okay, we are collecting samples and we are taking data of patients admitted in a hospital. Okay, so for them we have administered some medicines. Okay, so we want to test the efficiency of the medicines. Okay, whether the patients are get cured because of the medicines or not. So we'll be taking some values. Okay, so we'll be taking some values. We'll check that whether based on those values, we'll check that whether those medicines is having effectiveness on that particular sample or not. Okay, or another circumstances if you want to take, we know the for example, here one example is given that United States Environmental Protection Agency has set some policy that the pollution in the air. Okay, so it should not be more than 100 micrograms. Okay, 100 micrograms is the standard, they said. So they want to test whether it is there in that particular area or not. So what they can do, they can collect the data from different households and they can have the data. Okay. So that data can be tested with the population mean. Okay, population mean here is 100. They set the standard. Okay, so here with this population mean, we can test the sample whatever we collected whether this sample mean is aligned with the sample population mean or not. Okay, so this is one example. Another example, if I want to say, for example, we can have that the mean blood pressure is at 120. So we are collecting data from some 30 sample. So those 30 samples blood pressure we can take. So that blood pressure, if we are using t-test, we can get some mean value. Okay, mean value in the sense just adding those 30 values and dividing by 30. That is not we are not doing a t-test. What we are exactly doing in the sense, we are from the big population, we are taking some sample, whether this sample is a suitable sample or not, by finding out the mean. Okay, how much that sample is deviated from the population. That's what exactly we are doing it in the t-test. So what we need to do is, we'll be taking the values of those samples, and we'll be finding out mean for those samples values, and that mean will be comparing with the population mean. If it is deviating from the population mean, if it is generally the t-test value, whenever it is getting higher, it means that it is deviating more. Whenever it is getting lesser, it means that it is deviating less. That is the general interpretation we need to take from the t-test. So from this, we are able to say that whether this sample which we have selected is aligned with the population or not. Okay, so that's what we are generally using under one sample t-test. For this, we are taking only one variable from the collected sample. For that variable, we are testing with the population whether it is deviating from the population mean or not. Okay, so next to this, so generally hypothesis will set like this: population mean is equal to sample mean. The null hypothesis and alternative hypothesis, you might be getting awareness about it. So null hypothesis, we generally for one sample t-test will set the null hypothesis. Sample mean is population mean is equal to the sample mean, and the alternative hypothesis we take that population mean is not equal to the sample mean. Okay, it means that if H0 is accepted, it means that the sample which we have selected is aligned with the population. If H1 is accepted or H0 is rejected, that means that the sample which we have selected is not aligned with the population. So next t-test is paired sample t-test. Under paired sample t-test, what we are using is the same data, same sample only, with the same sample. Okay, one population, one sample we have taken. That sample, how it changed over a period of time. Okay, for example, we need to take a data of the health related data. Okay, for example, if any medicine is found for diabetes, we need to take the data before the administering that particular tablet or the medicine. Okay, before administering the medicine, what were the result? What were the level of their sugar? Okay, so that we'll be taking it. And after administering the medicine for 1 month or 2 months, then we'll be collecting the data again. Now we need to compare these two the same samples only, but we have taken the data in 2 different time period. So that 2 different time period data, we'll be finding out the mean. We'll compare the mean. Okay. So this, if we want to, since most of us are from academic background, we can take a example from that. For example, we are having a student of 50 in a class. Okay, so we are conducting some remedial classes for them, or we are conducting some training classes for them. So before the training, we can conduct a test for them. We can take a marks of those students, and we can have a 1 month of training to the students. After 1 month, we can again conduct the test. We can take the marks. Now we need to compare whether is there any effectiveness on that test training which we conducted or not. How we can do this in the sense, we are not actually taking all the population. We can take some sample from the class of 50 or 100 students. So what we need to do, now we can take all the first set of data. Okay, first set of data. For that, we can find a mean. And after 1 month or 2 months of training, again, we conducted a test. Again, we got some set of values. So for that, we can find a mean. So if there is difference in these two means, okay, it means that if their scores are improved because of the training. If there is no difference in the mean, it means that it is equal, both the means are equal. That means that there is no effectiveness through the training. So like that, we are able to make interpretation from this paired sample t-test. Okay, so that's what given here, that generally for the same variable in a different situation or under different conditions or different time period, we are collecting the sample, we are comparing them whether is there any effectiveness or not. Generally for this medicinal field, they'll be using this paired sample t-test. We also want and this this actually widely used for that medicinal purpose only, but if you want to use it for academic purpose, as I said in the example, we can use it. If you want to use it for training of employees in HR field, also if you are collecting any sample in HR, if you are doing any research, you can collect the satisfaction level of the employees. Okay, we will be having generally 5-scale rating. So before the training, what is their satisfaction, we can collect. And after the training, what is their satisfaction? We can collect the data through 5-scale rating. So now what we can do, we can compare these two through pair sample t-test, and we can identify that is there any effectiveness through the training or not through the responses. Okay, so that is a use of paired sample t-test. And next to this, and if we have more than two, if we want to compare more than two means, then we cannot use t-test, because t-test generally we use for two groups only. So if you want to compare, for example, that test is taken for 3 different time period, or after 2 different kind of training is given to the employees, that has to be compared. That means before the training and after first training, after second training, if you want to compare more than 2 groups, then we cannot use t-test. For that, we need to use ANOVA. Okay, so through ANOVA, that we'll be having the next day. Tomorrow, you may be having ANOVA session. In that, they'll be telling you how we can have 3 different samples, and that can be analyzed. Okay, so this is that means 2 sample we are using, 2 set of data we are analyzing in paired sample t-test, and here also we are taking the null hypothesis and alternate hypothesis like this. Null hypothesis, we are taking that mean of first sample is equal to mean of second sample, and alternate hypothesis, we are taking mean of first sample is not equal to the mean of second sample. If H0 is accepted, that means that both the mean are equal. That means that there is no effectiveness in the training, or there is no effectiveness in the medicines we administer. The second one, H0, alternate hypothesis. If H0 is rejected, means we need to accept H1. That means that mean of first sample is not equal to the mean of second sample. That means that there is some effectiveness because of training which we have given for the employees, or the training which we have conducted for the students. Okay, so like this, we need to take the interpretation. So when we are doing the test, I'll be telling you. And the next to this is independent sample test. So under independent sample test, we are not taking the same set of people, we are taking different set of people. Okay, so for different set of people, we are same level, same thing. T-test means generally we are comparing the means of 2 groups only, or means of a single group with the population. Okay, that is one sample t-test. In that, we are comparing the means of one group with the population mean. And paired sample t-test means we are comparing means of 2 samples. And here, independent sample t-test, independent, the name independent itself says that it is 2 different groups. Okay, 2 different groups, not the same group. What we did in paired sample t-test, we had one group. For that group, before the training and after the training, we tested. But here what we are doing, we are taking 2 different groups. Okay, those 2 different groups, we are comparing their means. From that, we are interpreting whether which group is having more satisfaction, which group is having less satisfaction. If, for example, in same HR training, if you are taking, we can take male and female, or different age group of people are there, and their satisfaction can be collected. Okay, so through that, we are taking different groups, and those different groups we are testing, and we are finding that if means are equal, the training which are given to the employees are equal level, or all the employees are taken the training in an effective way, and it has an impact on the employees irrespective of their age group. Or if there is deviations in the mean, it means that the training which are given to the employees are having variations and deviations, and the employees are not getting the training in the same way. So like that, we are able to make interpretation. So based on which test we are taking, based on that, the interpretation can be changing. Okay. So here, so we can use this independent sample test for under these circumstances. Statistical differences between means of two groups, or statistical differences between means of two interventions, or statistical differences between the means of two change scores. For example, the example which I said, that means that we are conducting a training for students. So there can be male and female students, and what is the effectiveness of training on that male students and female students? How much is their effectiveness? Based on that, we can say take some actions. Okay, if there is effectiveness on male student on the training which we are giving, okay, if there is no effectiveness, then we can change the style of training. So like that, we are able to take interpretation and make use of the data analysis, and we can make use of we can make some changes in the pattern of training which we are giving. So these are the common uses of independent sample independent t-test. And we'll be having the hypothesis like this: H0 is equal to, since it is also two sample, mean of first sample is equal to mean of second sample, and H1 we will be taking mean of first sample is not equal to mean of second sample. Okay, so if mean is same, the training which we have given is having effectiveness in the same way on both groups. And if H0 is rejected, it means that there is variations among the different groups. It means that the training has to be changed. Like that, we can interpret from that result which we are getting from the analysis. Okay, so this is about this, and this is a summary of whatever we discussed now. Okay, so you can make note of this, because we are going to do analysis and example for all these three: one sample t-test, independent sample t-test, and paired sample t-test. We'll be sharing the screen for analysis.
Meanwhile, participants, you also please be ready with the daily data set which we have shared yesterday's session. It will be helpful for hands-on training.
So I'll be sharing the Excel sheet which is shared with you yesterday. That you just can rename in that yesterday which is shared may not be having this variable names, so you can rename that. First one is about gender, and second column is age, and third column is before the training, the effectiveness or the satisfaction of the employees before the training, and second one is during the training, and third one is after training. We just will be comparing before and after. I'm not giving a name for the variables of other categories. We're just going to compare the before and after. So like this, you can rename and do the first. We'll do one sample t-test. So for one sample t-test, this will use it for independent sample, independent t-test, and one sample I'll be showing you on a simple example, and the same thing can be done for this also. So you can open SPSS. I hope yesterday you got input about how to use SPSS, how the data is decoded and can be used in SPSS. I hope you received it yesterday. So here I am going to open the file. So I hope you know that here, once we need to go to the SPSS and we need to click the option file and open. Under open, we need to click data, and here by default SPSS file type used to come, and we need to select Excel type, because generally nowadays we are collecting data through Google form, and the data we are downloading from the Google form through Excel sheet, so we can take the data in Excel sheet. So here I have some data. So you can click which data you want, you can click the data. Yes, sir. The screen visible? Okay, I'll share it again if it is not visible. So you can go to the SPSS. Is it visible, sir?
Yes.
So you can go to, yeah, you can go to SPSS data sheet, and you can go to file menu, and you can click open, and you can click data, and here you need to select the file type as Excel. By default, it used to be in SPSS. You need to select Excel, and which data we want to test that we can take. Okay, so I'll take a data here. So worksheet, generally, if you have data in different sheets, you can select which sheet you want. I have only one sheet, so I'm selecting the first sheet. So I'm taking the data here. So here we have taken two sample. Okay, so ward A and ward B. In two set of samples, the values are taken. That means these are hemoglobin level of the patients taken in two different wards after administered the medicines. Okay, so since we are using one sample t-test, we just take one set of data, one set of sample. Just a minute, I'll share the screen again. Yes. Yeah. So I have taken this data. Okay. So this sample I have taken. There are 2 wards in a hospital, and in 2 wards, two set of patients are there. Okay. So they have been administered 2 different medicines. Since we are using one sample t-test, I'll be removing this. We don't want this. I clear this data. So here there are 12 patients admitted in a hospital, and they have been given some medicines. Okay, medicines for their level of hemoglobin, to increase the level of hemoglobin in their bloods. Some medicines are given. So we are testing them. Okay, so whether the sample which we have taken, we have a sample universal hemoglobin level of 12 point. Okay, so that 12 point, whether it is aligned, the sample which we have taken is aligned with the universal value. Okay, since we know the hemoglobin level is 12.5, okay, so that we can take as a population mean, then we can test the sample with a population mean. So here I have taken it. So the same thing as I already said, you can take this for student marks. Okay, so if you have selected some students, okay, for the training purpose, so you can select their, you can get their marks. Okay, so we have a benchmark like 35 marks is a pass mark. If the student secured 35 marks and they are above average, like that we used to interpret. Okay, so that interpretation we can do. So we are getting the data here. Okay, so that we are going to, since that's what I'm saying. So one sample t-test we are using where we know the universal or population mean. Okay, so if we know the population mean, then we can use, or we can have a standard mark. If we have that standard marks, then we can compare. Here we have taken some 12 samples, and those 12 samples are the values of hemoglobin. Okay, so hemoglobin 12.5 is the standard value. With the 12.5, we are comparing the population sample values with the population mean. Okay, so here the data is there. Now we are going to do the analysis. So click the analysis, and you can, here for all the t-test, we need to go to the analysis menu, and in the analysis menu we need to click this compare means. Under compare means only we have all the 3: one sample t-test, independent sample t-test, and paired sample t-test. Okay, even now also you will be having under this menu only. So compare means, and there we are going to one sample t-test. So under one sample t-test, we are taking the test variable, and the test value we are doing 12.5 because we set the standard that 12.5 is a standard value. Okay. So now we can click OK. So is the output menu, output sheet is visible. Okay, I'll share the output. Yes. So this is the output we get. So after we did that analysis, so this is the output. We need to take these 2 table. Okay, so we need to consider these 2 table. This is about the interpret, and this is about the analysis from the sample which we have taken. Generally, we'll take this table for the interpretation. So here, if you see that here this 95% confidence level is given. Okay, so generally there are 3 categories: 90% confidence level, 95% confidence level, and 99% confidence level. When you are clicking the analysis, there itself you can decide which percentage you are going to give. Generally, we used to give 95% confidence interval. It is about how much we are confident about the sample we have collected. Okay, so that we are using, we are giving it to 95%. So if we are giving 95%, okay, so here the data is getting like this. Okay, so t value here, we no need to bother about the negative or positive value of t value. We just to take the values alone. Okay, irrespective of either positive or negative, we need to take the value. Okay, the value we got is 0.162. And degree of freedom generally use the formula n minus 1. It is 11 given here. And what we need to mainly taken from this output is this significant level. Okay, so this significant score of two tiled. Okay, so that generally we used to say as p-value. P-value means it's a kind of probability. Okay, so how much probability it is about by chance we have taken the data. That is a general interpretation, but how we need to do the interpretation in the sense, take the significant value, it is 0.874. So if the significant value is less than 0.05, then H0 is accepted. Okay, so I'll take it to the Excel sheet. I'll take this out to Excel sheet. So here we can take, if you are doing a research, you can take a result, and this result alone, if you are taking, or if it is a one sample t-test. Okay, so this result we can take. So test value we have given 12.5, and this is about a variable name, and this is t value what we are getting, and from that we are getting the p value is, that means 0. Our significant or two tiled value is 0.874. Okay, so if this value is less than 0.05, it means that H0 is accepted. So if this value is greater than 0.05, because why we are taking 0.05 means the confidence level we have taken is 95%. So that we are taking the remaining, that means percentage, 5% is the remaining, the by chance. Okay, so from that only we are taking this value. So generally you compare this significant value with the 0.05 value. 0.05, if you are taking 95%, that is a standard value. Okay, so if the significant value is greater than 0.05, H0 is rejected. So this interpretation is same for all the three tests. Okay, so based on the H0 what we are defining, we can give the interpretation. Okay, so this is same. Less than 0.05 means H0 accepted. Greater than 0.05 means H0 rejected. It is based on this value. Okay, so highlight this value. So based on this value, we can give this interpretation. So based on this, we are giving this interpretation. Okay, now if H0 is what we have taken for one sample t-test in the sense, H0 is, I'll show you the slide where we have discussed about how to take this. Yeah. So we have discussed like this. Okay, if it is one sample t-test, H0, we used to say take that population mean is equal to sample mean. If population mean is sample mean, that is H0. If H0 accepted means population mean is equal to sample mean. If H0 rejected means population mean is not equal to sample mean. Okay, so here in the output we got that this value is greater than 0.05. That means H0 is rejected. That means that population mean is not equal to sample mean. Okay, so the universal value 12.5 is not aligned with the sample which we have collected. Okay, so that interpretation we can take. So in the same way, if you are taking any test related to your student training effectiveness or employee training effectiveness, there also you can compare. You can have a benchmark values. With that benchmark value, you can compare the data which you have collected, whether the sample which we have collected is aligned with this population or not. Okay, so this is what we are doing, one sample t test. Yes.
Okay, you can unmute yourself.
Sir, how did you arrive that value of test value? No, when we opened normally when we start with the one sample t test, it's asking for the test value. It says 0. So how we need to arrive for whenever we are doing this?
Sorry, ma'am. Can you come again? Is your doubt why do we take this 12.5 value, ma'am?
Yes. How we have arrived to the test value of 12.54?
And that's what, ma'am. This one sample test, one sample t test, we are able to do only if we know the standard value. Here we have taken the sample of 12 patients of their hemoglobin level. So hemoglobin 12.5 is the average value. Generally, doctor used to suggest us that 12.5 value if we have, that is a good value of hemoglobin. So that we are taking as a population mean. In the same way, that's what it is suggested. If you are using sample one sample t test, we must be knowing the mean of the population. If for that's what I am telling. If we are using, if we are finding out the effectiveness of training which we are giving to the students. So what is the pass mark we are having? 35 is the pass mark. So we can have this value as 35. So by having this test value as 35, then we can test the marks scored by the students. So this that is a general assumption that if we know only the population mean, or if we know some standard value for the population, only then we are able to use this one sample t test. I hope you are able to get it, ma'am.
Yes. Thank you. Now I understand.
So now here, this H0 is rejected here because the significant value is greater than 0.05, then H0 rejected, H1 is accepted. So the sample mean is not aligned with the population mean. So now this is one sample t test. So now we are going to do the paired sample t test. Go back to SPSS. Just a minute, I'll share the screen. So now I'll share the screen. So we'll go back to SPSS. We go to the file, open data, and as I already said, is the screen visible?
Yes.
So we'll change the file type as Excel, and we'll take a data, we'll open it. Yes, we'll have it like this. And here we'll go to the data view. So here 11 students are taken, their roll numbers are given, their marks before the test, before the training, and their marks after the training is taken. Just a minute, I'll share the screen. So if we go to, is it visible, sir? So if we go to the SPSS data view, so there are 11 students, their marks before the training and after the training, before the coaching and after the coaching is taken here. Okay. So now for this, we are going to do the paired t-test. Through that, we are going to compare the means. Okay. By comparing the means, if the means are equal, that means that there is no, just a minute. Yes. So we'll go to the data. Okay. So analysis, we'll go to the analysis and we'll go to compare means and we go to paired sample t-test and here. And before that, we need to change the data type in the variable view. And it has to be nominal because two nominal value only we are able to compare, one nominal, one scale. But for next test, independent test, we need to compare only one nominal, one scaled variable. But here in the paired sample t-test, both has to be in the same type. So it is also nominal data, and this post-test and pre-test, both we are changing the name of the variable. Okay, nominal and nominal. So now we'll go to analyze, compare means, paired sample t-test, and here you will be getting this window. I hope this window is visible to you. And here variable one is pre-test. Click the pre-test and click the arrow mark, and variable one is pre-test and variable two is post-test. So pre-test and post-test we have taken as two variable, and then we are going and comparing them. Okay. So now if you click OK, we will make the analysis. I'll share you the output window now. Yes. So this is the output we are getting by doing the analysis. So the last one, and I'll copy this table over there. I'll copy this to Excel sheet. I'll be explaining that. How do we interpret it? And if you have noticed it, you might be, if you have noticed it, there is a correlation value also that actually not necessary here for the t-test. So if you want to do the correlation analysis also, you can do with the two values. Okay, here the correlation value is 0.550. It means that it has a moderate level correlation between the two data. Okay, so there is some correlation among pre-test and post-test. That interpretation we are not making here. We are making interpretation for the t-test actually. So I'll share you the Excel sheet where I have copied this output. So here, so these two we have taken from the system. you just click copy. I'll paste it. I'll go back to the Excel sheet. I'll explain to you. So I'll share this Excel sheet. So now, so this is the result we got. So here, if you see, T values are salary set. So this, if you want to write a report, you can take this also, and whichever the data is not relevant to us, that we can delete. So standard deviation, generally we don't consider, that we can delete, and standard mean error also we can delete. So we need to take this T value, that T value we can take. So this T value we'll take, and we'll take this significant value also. So this is a significant value that we say as P value. This P value or significant value, you can say. So now, as I already said in the previous analysis, this is the interpretation we will be taking. So this we don't want because we have taken the value over there. So now we can compare this P value. If it is less than 0.05, okay, H0 is accepted. If it is greater than 0.05, H0 is rejected. Okay, so here this P value is 0.02. Okay, so it is lesser than 0.05. So it means that this H0 value is accepted. Okay, H0 accepted means we have seen it, the interpretation. I'll show you the hypothesis which we framed for paired sample t-test. So this is the hypothesis we framed. Okay, H0 is mean of two samples are equal, and H1 is mean of two samples are not equal. Mean of two samples are equal in the sense that means that before the test and after the test there are no effectiveness because the mean is being same. Okay. So as I already said, we should not directly add all the values and divide by the total numbers. Okay, so that is not actually the mean which we are finding. Okay, so what we are exactly finding in the sense, we are finding the sample which we have selected from the population. Is it being the exact sample which will reflect the result of the population or not? Okay, that's what we are going to interpret. So by seeing the values, you cannot say that. By seeing the values here, I'll show you. So in that data which we have collected, sorry. Just a moment. So the data which we have collected, by seeing the values, we should not say that. So these values are, but the marks are less in the pre-test and the marks are high in the post-test. So there is effectiveness, that we should not say, because we are collecting the sample. We are collecting sample from the population. So those mean we are actually what we are doing in the t-test in the sense, we are calculating how much it is aligned with the population, the sample which we have taken. So that whatever the interpretation we are giving, that is not that we are not giving it for sample, that the interpretation we are giving it for population. Okay, so whether it is aligned with the population or not, that we are giving. Okay, so if we see the interpretation for the last result, H0 is accepted. H0 accepted in the sense the mean of both variable is equal. If mean of both variable is equal in the sense, there is no change in the mean. If there is no change in the mean in the sense, the test which we have given is not reflecting in the population. Okay, So it is not the population, the mean is not mean is equal. It means that there is no effectiveness from before the training, and there is no effectiveness after that. There is no effectiveness after the training. Okay, from the data which you have taken, we are able to interpret like this. Okay, so this is paired sample t-test. This we are doing it for comparing the same sample and in two different circumstances. Okay, so that is paired sample t-test. And next we'll move to independent sample test. So for independent sample t-test, we'll be taking two different set of data, or the same data, two different set of data. So I'll take a yes. So here you can take the data set which is SAD yesterday. So by using that, I'll be explaining you. So open a data file. You can change the type as Excel, and you can take this data set. Yeah. So let's check it again. So this data set, and as I already told you, I hope you renamed into gender, age, before training and during the training and after training. Okay, so now we need to do the analysis for this. Just a minute. So the same procedure we need to follow for going to the analysis page. Just a minute. So I'll be sharing you that. Is the screen visible? Yes. Yes. So this is a file shared with you yesterday. So in that, I have told you to take and rename the variable. First one is gender, next age, then before training, during training, after training, what is the satisfaction level of the employees. Okay. So here we are going to do the analysis. So analyze, we can go to compare means, and we are going to do independent sample t-test. Okay. So here we are going to make the analysis of two different groups. We'll take gender. Okay. So gender will take, here it is given 1 to 1 to 1 is indicating male and 2 is indicating female. Like that only we rename. And what you need to do is take the variable which the group which you have grouped, okay, that you can take under grouping variable. So from here we have taken as a grouping. I'll take back and so here if you click the analysis, you will be getting page like this. So in this you can take test variable is training. So training effectiveness we are testing. So take that under test variable before training. Okay, after training. So these are ordinal values. Do analyze, compare mean, independent sample t-test, and after the training effectiveness, we need to take this video. Okay, after training, and here grouping variable is gender. So gender we need to click, it has to be here, and from this we can take gender here. Okay, so we need to define the group 1 and 2 for male 1 and female 2. So we define the group and we have taken the values after the training, and we are going to test is there any effectiveness in the means after the training for male and female. Okay, so now we can test it. So if we test it, we'll get value like this. I'll share you the output window. Yeah, so this is the output we are getting after training, male and female. After doing the training, what is that mean? Okay, so the training which we have given is having effectiveness on same effectiveness on different groups or not. That's what we are testing here. Okay, so this table only we need. So this will copy and take it to the Excel sheet. So we'll take it to the Excel sheet. We'll copy it here. So this is the independent sample t-test which we conducted, and this is the result. And we need to do the interpretation. This is the interpretation. They have it. And here we need to take the data, the same significant value only. So significant value of equal variances assumed. Okay, not assumed we don't need to take. We'll take equal variances assumed. Okay, so here we need to compare these two value, whether it is less than or greater than. Okay, so here if you take, so I'll share you that hypothesis what we need to frame for this independent sample t-test. So for independent sample t-test, we'll be assuming the hypothesis or framing the hypothesis like this. Such not is mean of both is equal and mean of both is not equal. H1 is alternative hypothesis, mean of two samples are not equal, and null hypothesis, mean of two samples are equal. Okay, so we'll go back and we'll check what result we are getting. And here H naught is that means the significant value which we got is greater than 0.05. Okay, so greater than 0.05 means H naught rejected and H1 is accepted. Okay, so this significant value is greater than H naught greater than 0.05. Greater than significant value is greater than 0.05. So we are rejecting the null hypothesis and accepting the alternate hypothesis. Okay, alternate hypothesis what we have taken, mu1 is not equal to mu2. So the mean which we collected between the two samples. Okay, so the training which we have given for the employees or the satisfaction of the employees of male and female, okay, is not equal. That means that they got the training in a different level. Okay, so different kinds of training is given, or the effectiveness on different group is not same. Okay, so they are having different levels of effectiveness, and based on that we are able to make changes in our training. So we can give different set of trainings for different gender which is having less satisfaction. Okay, so by giving that we are able to increase the effectiveness and we are able to get a same level of mean. Okay, same level of mean in the sense same level of satisfaction among the different groups we are able to get it. Okay, so this is the interpretation we need to do from this particular test. Yeah, so this is about independent sample t-test. Okay, so I hope you got all the three tests, one sample t-test and paired sample t-test and independent sample t-test. So these three tests are used under three circumstances that I told you to take it from this. So here, yeah. So from this you can take for which we are doing one sample t-test, for which we are doing independent sample t-test, and for which we are doing paired sample t-test. We are able to take it from this. Okay, I hope you got a very good input from this session. Thank you for your patience listening. If you have any doubt, you can ask.
Presentation. Dear participants, if you have any questions, kindly raise your hand or allowed to unmute yourself and ask. Any questions are there, or if you want to put it in the chat box, that is also fine. Any questions, dear participants? Yeah, ma'am, you can ask the question, ma'am.
Sir, actually, you were changing the values of the scale values, like so nominal, ordinal, everything in the variable view.
Yes, ma'am.
Is there any specific reason that why you have changed from that nominal to ordinal in that variable view when we are using the sample t-test?
Ma'am, which kind of variable we are using based on? I hope you attended the first session.
Yes, sir. That time, madam told that she will be explaining that later when you have to use the nominal and when we have to use the ordinal.
No, my first session taken by Somasundaram sir, ma'am, day before yesterday. Sir explained.
Yes, sir. Yes, sir. We know the meaning of that, but exactly we don't know which scale we have to use it when we are applying the concept.
Yes, ma'am. For this independent sample test we are using now, ma'am. For independent sample t-test, we need to use only two different variable, ma'am. Two different variable in the sense one has to be the nominal one. Okay, another one is ordinal one. Only ordinal and ordinal, nominal and ordinal, because two groups we are using. Okay, so two groups in the sense male and female. Male and female is ordinal variable, and the satisfaction which they are getting is scaled variable. So that if we are using two different variable, only then we are able to get the result. For example, we cannot in independent sample test, we cannot compare the satisfaction, the data which we got after the training and before the training, that 1 to 5 rating scale, that two data we are not able to compare, ma'am, because we are using the independent sample test in order to find out the effectiveness on two different groups, not two different periods. Okay, so that actually we are doing it in paired sample t-test, where we are comparing the data of two different time period. For that, we must use on the same variable. Nominal and nominal only we used to use. But this independent sample test, we are comparing with the two different groups. So we need to take one variable as a nominal, another one is ordinal. That's what, based on which test we are taking, we need to make a changes. For one sample t-test, no issues. Directly we'll be taking only the nominal value. For the nominal value only we'll be doing the test. And paired sample t-test, both are nominal value will be taking. And the third one, paired sample, independent sample t-test will be taking one as nominal, another one as ordinal, like that, based on the test which we are taking. I will be sharing these slides to you. So in that it is given, ma'am, for which test we need to take which kind of data. Are you able to get it, ma'am?
Yes, sir. Yes, sir.
Thank you.
Thank you, sir.
Thank you.
Participants, any more questions are there? Okay, thank you. Thank you so much for your active participation. I thank Prof. Haribhaskar for a detailed presentation. And hopefully we will join for day 4 tomorrow. Professor Somasundaram will join for us to demonstrate factor analysis, the next stage of calculation. So have a pleasant evening, and we will join tomorrow for day 4 session. Thank you so much. Have a great day.